Thank you, everybody, for being here this afternoon. I'm going to start with this demonstration that is about fog-assisted robotics. Before delving directly into the demonstration, I'd like to give you some background of what fog-assisted robotics is. Nowadays, we have cloud robotics. The main rationale of cloud robotics is to use cloud computing for empowering the robot's capabilities. So in the cloud, there are a lot of servers, a lot of computational capabilities, storage, etc., that can help robotic system and enhance their operation. There is a problem nowadays with the cloud robotics. That is, the cloud resides far away from the robots. In order for the robot to communicate with the cloud, the message needs to traverse one or more networks. So when it comes to more stringent SLAs that are required for some robotic services, it's very difficult to do it via cloud robotics. So we need to enhance, evolve this concept and bring it down to the edge and fog. So the idea is to bring these capabilities for robotic services down to the edge and fog. In this way, more stringent SLAs can be enforced for robotic services. And also there is another great benefit for doing this, that by using this concept of edge and fog, specifically with the platform that we are envisioning in 5G Coral, the surrounding devices can be reused by anyone for any services. So by using the 5G Coral platform and this concept of edge and fog, there is no need for robotic services to deploy an ad hoc architecture for robots as it is done nowadays. Having done this premise, what is the use case that we are going to see in this demonstration? The idea in this shopping mall that is an indoor scenario is to use a fleet of robots to have a cooperative delivery of large items. The idea is you have got many shops in the shopping mall that they need to restock their items. So let's automatize this, and let's use a fleet of robots that are fog-assisted. We are going to see later what does it mean being fog-assisted, to bring large items directly to the shops. So the restocking will be much easier and automatized. We take, in this demonstration, the concept of empowering the capability of the robot to the extreme in case of the fog. That is, we remove any intelligence from the robot itself. We bring everything to the fog. So in this demonstration, the robots only act as sensors and actuators. So they sense the environment, they stream the data to the fog. The fog will compute whatever it needs to compute, and will send back commands to the robots. An additional thing is that peculiar to the edge and fog system that is not available in the cloud is the use of context information. In the cloud, there is no knowledge about the access network, while you can have this knowledge in the edge and the fog. So this knowledge can be used for enhancing, optimizing the operation of the robots. As you can see here in this screen, we are seeing the live Wi-Fi signal of our robots that are over there. You can see, if you turn around a bit, you can see that against the gray wall, those two robots are our robots. And this is what is being seen in the fog as a context information for that. This information is used for optimizing the movement of the robots. Then in this demonstration, what we are using is the robot operating system that we use as a framework for robotics deployment. It's a pretty widespread framework worldwide. And we use that for implementing the brain. What is the brain? What you're going to see now, that the intelligence of the robot is a synchronized and cooperative delivery of items. So the robots will be driven by the fog in a synchronized manner. And we are going to see an automatic navigation of the robot through this path. At this point, the shop owner can use a sort of a portal application where it can select which item to restock. At this point, for example, a shop decides, selects one item. At this point, the robots will go information, getting ready for delivering the large item. Once they get information, our colleague Milan, still from UC3M, will place a large box on both robots. Okay, at this point, Now the robots are being controlled by the intelligence, by the ROS intelligence in the fog. So everything is controlled in the fog nodes that are on the ceiling. Yes. Now that autonomously you arrive here for the delivery of this box, and we'll just stop here. At this point, I can remove the box that arrived to the shop. And again, with a similar application, like here, I can send back the robots. At this point, the robots are still automatically navigated back home, but at this point, they are not synchronized driving. Okay, one stop. Okay, now it's going. The cleaning. No. Now, at this point, we can reuse the same platform. We have seen an example of application that is the synchronized delivery. There is another example of a robotic application that is the cleaning, to use robots to automatically clean the environment.
At this point, the robot will continue to its destination, and once it gets here, it will perform the cleaning operation, in our case, which is the Roomba spin around, and then after that, it will be instructed to go back to its docking station.
So basically here, what we have seen is that the control follows the robot, as we have explained in the previous slides. Okay? So what we have is all the control of the robots is on the fog, and will follow the robots while they travel through the shopping mall. Okay?
Yes, so now it's spinning around, representing the cleaning effort. And once this cleaning is done, it's now going to instruct to go back to its docking station.
So now it's cleaning?
Now it's going home.
Okay,
so
Lucas,
back to you.
So concluding this demonstration, I am reporting here some next steps. So what will we be doing for the next year of the project duration will be to use the Wi-Fi signal, the context information, as a way for course localization, to enable also a better live migration of the intelligence, and also the access point for providing a continuous coverage across all the shopping mall. With this, I conclude the demonstration. Thank you for your attendance.